Alright, so number 41, the 1 kilogram physics book in this figure is connected by a string to a 500-gram coffee cup. The book is given a push up the slope and released with a speed of 3.0 meters per second. The coefficients of friction are as follows. A, how far does the book slide? And B, at the highest point, does the book stick to the slope or does it slide back down? In this figure, we have a rope connecting the cup and the book. We have some sort of like rotating pulley of some sort, and we're going to assume that the pulley has no resistance to motion or anything like that. And then we also have this 20-degree angle from here to here, and that's what this little 20-degree angle is here. So how do we approach this question? Well, we're going to start out with the things that we know. So we know the mass of the book, the initial velocity of the book, and its frictional coefficients. And we also know the mass of the cup. And I decided to change the mass of the cup into kilograms, so it matches up with the units of the book, and also just the units of forces are in kilograms. So how does this look in terms of forces? So we have this, I drew this really weird free body diagram because I think this is more demonstrating of the forces than a regular free body diagram, and it also puts into perspective of what's going on. So we have this velocity going upwards, which isn't a force, but it's good to have here to remind us. And we have a downward force of the book just bringing itself down with its own mass, and the kinetic friction. And the reason we are using kinetic friction is because the book is moving, and we use kinetic friction when there's friction in opposition to motion that's already happening. And then we also have this force of the cup. So all the downsloping forces, we need to calculate those first. And so the force of the cup is equal to just the force of gravity acting on the cup, which is 4.9 newtons. The force of the book is a little bit more complicated. It's just a sine theta of the force of gravity on the book, and that's because of trigonometry. If we have the force of gravity on the book acting right here, then the 20-degree angle is opposite to it, and we just multiply it by the sine of 20, and we get 3.35 newtons. And then the force of friction is equal to the friction coefficient times the cosine theta times the force of gravity acting on the book, and we're going to use the kinetic coefficient, and we're going to get 1.84 newtons. So the total downsloping forces is equal to 10.09 newtons, and the total mass is 1.5 kilograms. Now we're just going to use kinematics for this situation, and we know everything except for the acceleration, and we need the acceleration to find the distance that the book will travel. So the acceleration we know from Newton's second law is equal to the force divided by the mass, and so we're just going to do all that, and we get 6.73 meters per second squared downsloping. And so it's going to be a negative number, and we just plug it into our kinematics equation, and we get 0.669 meters, and that's how far the book continues to slide. Now B is asking when we reach the highest point, when the book reaches its highest point and then stops. And we're going to see if it continues to stay at rest or if it slides back down. So when velocity reaches 0, the friction switches direction, because friction switches direction and also just switches types, because now we're at rest. So we're going to be using static friction, which is the friction opposing motion on an object that is not moving at all. So downslope, we no longer have friction moving in the downsloping direction, so it's just going to be the force of the cup plus the force of the book, which is 8.25 newtons. And then the maximum static friction is going to be 4.61 newtons, and we're just going to be using the same equation from up here for down here, just instead of the kinetic friction coefficient, we're using static. And that's going to be 4.61 newtons. And because the downsloping forces are greater than the static friction force, then we know that the book will slide down. Now, the learning goals for this particular question was linear motion, kinematics, free body diagrams, and being able to draw them and interpret them and have them in ways that we understand personally. motion on a line, Newton's second law, and friction, and being able to differentiate between different frictions. All right, thank you very much, and I hope you have a lovely day.